and welcome back. This is week 2 of the medical image analysis course. So last week we were looking at the various medical imaging modalities, namely MRI, CT, ultrasound, and some nuclear medicine imaging. And we saw what the mechanisms are of image generation, right? So either other than ultrasound, most of the other imaging systems require a reconstruction process, right? There's no direct image acquisition. And we looked at the nature of those images, the nature of contrast, what the pixel values mean, etc. So in this vein, we are going to continue to look at some of the basic image processing techniques that you will end up using pretty much every time you start on an imaging project, right? So this is necessary for a wide range of imaging image types, starting from either MRI, CT, ultrasound, whatever it might be. So some of these are a requirement in many cases. So you will have to be familiar with some of them so that you can use them even if you're using, let's say, machine learning or deep learning methods as it's the state of the art these days. Okay. So in this video, we will mostly only be looking at the contents of this week's lecture. And just to give you an overview of what we're going to look at this week, and set it in context. Okay, so our topics, the topics we are going to cover in this week are contrast enhancement. Okay, so in a lot of cases, when you display the medical image on the screen or on the radiologist monitor, the anatomies are of interest are not necessarily highlighted. Okay, so there are various techniques to highlight a certain type of tissue, and that's the technique that we are going to look at in terms of contrast enhancement. We've got the window and level. Okay, so we will see what that is. The next technique that we look at is called histogram equalization or matching. Once again, this is done to improve the appearance of the picture. Okay, so the first one is more trusted. The contrast enhancement, where what we call the window and level, setting the window and level, is more often done. Because it doesn't really, change the meaning of the image, but histogram equalization can. Histogram equalization is good if you're going to do further downstream tasks. Okay, so we'll see what that histogram equalization does when you look at the process. Okay, and the other techniques we are going to look at is the edge enhancement using Laplacian, the second derivative you might be familiar with, as well as the derivatives. How we can compute derivatives on an image, right? Because the Laplacian derivative, etc., are defined mostly if you are on continuous functions, right? But the image is a discretized 2D matrix. So you'll have to see how to use the Laplacian or the derivatives on images. Okay. After that, we are going to look at a variety of techniques for filtering. Now, these filters appear in the context of denoising images. So a lot of times, the acquired image might not be of the quality that the clinician wants. Okay. In that case, we have to do filtering to remove the noise. Now, when we do filtering, you have to be careful not to remove anatomical structures or distort anatomical structures, so that there's a misdiagnosis can happen. So in that context, we look at some very simple filtering techniques like linear filtering, which is nothing but an averaging, boxcar averaging as it's called, median filtering. Diffusion filtering is slightly more complicated. Now, I won't spend too much time on diffusion filtering. I'll just give you the general principle. Maybe in week 3 or 4, when we're looking at related techniques, I might get into that. Okay, but at this point in time, as far as diffusion filtering is concerned, we will just look at the overall concept of how it works. Okay, just to give you an understanding of how there exists so many different techniques to do filtering. And the next one is the bilateral filtering. This we can go into slightly more detail as to the formulation of this filter. And of course, this is also a widely used filter in the clinic. It's a very slow filter in the sense that computationally it takes longer, but a lot of people have worked on improving the speed and making approximation, etc. But we will only look at the basic method as it was described in the original paper and understand its strengths and weaknesses. Okay. The last topic is the Bayesian image restoration, which is again is probabilistic technique for removing noise from images, where we actually propose models, probabilistic models for the image as well as for the noise, and then I do this Bayesian image restoration. Once again, as far as the Bayesian image restoration is concerned, we are not going to go into great detail as to how it's done. Again, just show you the general principle. And if time permitting, maybe in the future weeks after week 3 and 4, I will get into this in more detail. Okay. Just a note of warning, you will see a lot of formulas in this, right? Some mathematics, if you're not, I mean, but I think this mathematics is at the level of +1 or +2 mathematics. Okay. Now, if you are not comfortable with this, don't worry. There are lots of resources online. There are textbooks carrying this information. After all, it's a well-researched subject, so there's a lot of material out there. I urge you to go and read them. So do not be intimidated if you see a derivative, second derivative, a Bayes formula, or a bunch of exponential weighting schemes, etc., or median filters, etc., right? Or if I use the term, probabilistic models or things like that, do not get put off by it. At this point, you can spend a lot of time just understanding their pseudocode, or how do you take the formula and make it into a code. Okay, so you can spend time on that. That will help you understand this thing better. Okay. Also, at this point, I'm not showing you any demonstrations. I'll definitely show you demonstrations of these techniques on some good images and see what each of them do. Okay. But once again, like I said, well-researched subjects can find a lot of resources online about these filters, etc. Implementations of these filters will be available. In Python, MATLAB has an image processing toolbox. You should try it. All of them you can just try it from your laptop. Like many of them are not that computationally intensive in the sense that you can run it on a very simple workstation. So so even though it might be very mathematical, it will be. I'll present the formulas for all of these techniques. And if you don't be, I urge you again to be not intimidated, but rather try to understand what the techniques are in terms of working out the pseudocode. Try to see how you would exactly do the computations, etc. I'll also mention it wherever I can, and that way you can understand the techniques better. Now, once again, you might all be wondering, why do we need all this? Now there is deep learning, machine learning, etc. But if you look at a lot of these papers in machine learning or deep learning, there is usually a pre-processing step, especially for medical images. It's actually a requirement, I think. And it's good to know some of these techniques, because then you can apply them without worrying about what it does. Okay, so it's important you understand what each of this technique does, right? There are two ways. One is you understand what the output is, what its limitations are. The other one is actually understand the process, in the sense the computation is involved. Okay, so now there are again implementations available. So understanding the computations is good for you to and maybe you want to code yourself, and you want to write low-level code for all this. That's great. You want to develop your own image like fast libraries for all of these things. In that context, please go ahead and understand every little computation. But in the context of you want to do slightly more advanced things, so this becomes a basic step, and maybe you don't want to spend too much time on it. In that way, you want to understand what each of these operations do to the images. Okay, so broadly speaking, this is basically divided into this contrast enhancement, this histogram equalization matching. These are all I would call improving the enhancing the image. Now that's what this comes under, an image enhancement, right? The edge enhancement, etc. Laplacian the Laplacian as well as the derivatives or edge enhancement, that's more into processing, right? Because not too long ago, edge detection was a big thing. Okay, even now it is. If we have very good edge detectors, it's great. It's very useful, right? So, but that's what this Laplacian and the derivatives fall under. The other things are filtering. Again, they also are concerned with improving the quality of the image without distorting the anatomical meaning. Okay, so now we'll go into each of these techniques one by one and show you what the basic processing are. Okay, thank you.